About the distributive property. I'm going to point out two different methods for the distributive property. The first method is the order of operations. Now the order of operations, however, only works when you're talking about numbers, when there are no variables involved, because you can go ahead and you can do parentheses first and simplify that. So 90 plus 60 is where we get the 150, and then we're going to multiply it by 2. Excuse me, and 2 times 150 is 300. Now, I'm going to show you the distributive property that we use when we have variables, and we're going to see that even though we go about things a little bit different, we're going to start with the exact same equation, and we're going to end up with the exact same answer. But this is the method we will have to use when variables are involved. So, to distribute means I have a distributor, which is going to be 2, and I'm going to distribute it or multiply it by each part of the quantity in the parentheses. So you can see my first is 2 times 90 and my second is 2 times 60. I go ahead and I give the answers to each of those. 180, 2 times 90, and 2 times 60 was 120. And then when I put the two of those together, I keep that operational sign, my operational sign of addition there. When I put the two of those together, I end up with 300, the same as if I did order of operations. Now this screen, if you want to pause it, you can see that it is showing you how to do the distributive property. Again, there's my distributor, so A times B is AB, and then A times C is AC. In the next one, they simply put the distributor behind, so they said B times A, or I guess I could do that the same way that they did it. I could do B times the A and then C times the A, and that's where they got the BA plus the CA. This one here, notice that it is our first one that is subtraction. So because there's a subtraction sign there, there's also going to be a subtraction sign here. A times B, A times C. We're going to keep our operational sign. And again, the last one is just doing that in reverse. So let's go ahead and get down to it. The first of using the distributive property is when we have something that is a harder problem to work out mentally. So our first one is 3 times $5.95. Now I want to change $5.95 to an even dollar. So I'm going to change it to 6, the closest even dollar to it. Now, $5.95 is not $6. It's a nickel more than $6. So to get the $5.95, I need to subtract 5 cents from $6. So 6 minus 0.05, or a nickel, would give me my original question of $5.95. Now I have some mental math going on, and I'm going to rewrite this here a little bit, and I'm going to do my 3 times my 6 minus 0.05. This way I can write my arrows in. So my first thing I'm going to do is my 3 times 6, which is where they got the 18. And now I'm going to distribute 3 times 0.05, and that's where they got the 15 cents. I kept my operational sign, which was subtraction, and I can say $18 minus 15 cents, and that will give me $17.85, which involved mental math and was easier for me to calculate. Now, I could do it as an addition one. However, if I do it that way, I have 3 times 5, which is easy. That's 15. But notice my next would be 3 times 95. And now you've kind of lost the idea of making everything into mental math. Okay, here's some straightforward equivalent variable expressions, and we'll go ahead and we will practice our distributive property. Now you're going to see that I'm using the arrow as I'm speaking. You do not have to do that. I would caution you, if you want to start to use it, that is fine, but I would try to quit using it after you get used to the method, because as we get into more complex sentences, you're going to have more and more written down, and you don't need to add to the writing on the paper with the arrows. So I'm going to go ahead and I'm going to do 3 times x first on this one, and I will get my 3x. and then 3 times 7. And that will be 21. And carry down your operational symbol. Oh, that's not pretty. Okay, so 3x plus 21. Now, I'm going to do mine slightly different than the example in the book, and I'm still going to use my single term as the distributor. So I'm going to do -2 times n first, and then I'm going to do my -2 times 4, and that's going to give me -8. Now, my operational symbol comes from the negative times the positive in that case. And my last one, I'm going to do this one without the arrows. I will still be speaking. -5 times 2y is going to give me a -10y. Make sure you're applying your variable rules. And -5 times -3, that's going to give me a +15. And there's my operational symbol as a positive. My last example is going to be about geometric shapes and finding areas. Areas are length times width for rectangles and 1/2 length times width for triangles. So we're going to go ahead and we'll do the easier one first, the rectangle. And I'm going to use my single term as my distributor. So I'm going to write 7. And then I'm going to use my expression, my sum there. And let's see if I can write that a little bit nicer. That's a better one. Is what's going to be in my parentheses. Distributing that, I would have 7 times 2x, which is 14x. And then I would also have 7 times 5, which is 35. Now, I didn't mention this before, but when we write expressions, it's proper to write the variable first and then the constant term. If you need to change it around, especially in those reversed ones, make sure you keep the symbol that goes with the term. So if it's a negative number, you keep that negative with it when you change the order. Now our next one is going to be half the length times the width. So I'm going to go ahead and I'm going to write down my 1/2, and I'm going to first put my single term as I did before, and then I'm going to put my computation. Now I'm going to go ahead and we're going to multiply all 3 of these terms together. So the reason I put my single term here is I could go ahead and say 1/2 of 12. 1/2 of 12 is 6. And I'm still going to need to multiply 6 times 8 minus 3y. 6 times 8 is 48. I'm running out of room here. 6 times -3y is a -18y. Now, get some space here. As I was just saying about changing the order of our sentence, we want the variable first. So I want the 18y to be first, but notice it's a -18y. So if I really want to be fantastic, we'll give ourselves a gold star here. If I want to be super here, I'm going to go ahead and I'm going to rewrite the sentence as a -18y, and my 48 is positive, so it's going to be plus 48. And that would be the expression that would represent the area of that triangle. That concludes the lesson for 2.2.